The James Webb Space Telescope, JWST, stands as a premier space observatory of our time, leading the charge in unraveling cosmic mysteries. From the intricacies of our solar system to the secrets of distant exoplanets orbiting faraway stars. Its mission also includes exploring the vast structures that define our universe and understanding humanity's place within it. In a groundbreaking effort, scientists recently directed JWST toward a star located 120 light-years away from Earth. What they uncovered has captivated the astronomical community. Strong evidence pointing to the presence of carbon-based molecules in the atmosphere of a distant ocean world. This discovery offers a rare glimpse into a type of planet vastly different from anything within our own solar system and sparks new questions about the potential for habitable environments beyond Earth. In today's feature, we dive deep into this extraordinary finding, unpacking what it means for our understanding of exoplanets and the ongoing search for life in the cosmos. If you're passionate about space discoveries and want to stay updated, don't forget to subscribe, like, share, and hit the notification bell for future content. NASA's James Webb Space Telescope has turned its powerful instruments on the exoplanet K2-18b, a world that is 8.6 times more massive than Earth. What makes this planet so compelling is the detection of carbon-bearing compounds in its atmosphere, such as methane and carbon dioxide. These findings align with previous studies that suggested K2-18b may host conditions suitable for life. Evidence points to a hydrogen-rich atmosphere layered above a surface potentially covered in oceans. The initial atmospheric analysis of K2-18b, located in the habitable zone of its star system, was conducted using NASA's Hubble Space Telescope. This earlier work laid the foundation for the current, more detailed observations by JWST. K2-18b orbits a cool dwarf star known as K2-18, situated in the constellation Leo, 120 light-years from Earth. Exoplanets like K2-18b, those that fall between the size of Earth and Neptune, are not found in our solar system, making them a unique class of planetary objects. The potential presence of carbon in a hydrogen-dominated atmosphere intrigues astronomers, as such environments may offer favorable conditions for life. Notably, the detection of methane and carbon dioxide, combined with the apparent lack of ammonia, supports the theory that an ocean may lie beneath the planet's atmosphere. There's even tentative evidence of dimethyl sulfide DMS, a molecule on Earth primarily produced by marine plankton, though this detection remains weak and needs further verification. Additional observations using JWST will aim to confirm whether DMS is truly present in meaningful amounts. As one University of Cambridge astronomer cautioned, the presence of carbon compounds and location in the habitable zone do not guarantee that life exists on K2-18b. With a radius 2.6 times that of Earth, the planet likely has a thick, high-pressure icy mantle around its core, similar to Neptune, topped by a thinner hydrogen-rich atmosphere and possibly a global ocean. While liquid water may exist there, scientists still don't know whether such oceans are stable or extensive enough to support life. Nevertheless, researchers have achieved the most detailed atmospheric spectrum of a habitable zone sub-Neptune to date, enabling precise identification of molecules in its atmosphere. A Cardiff University team member explained that these insights were gained by analyzing the starlight passing through K2-18b's atmosphere as it transited in front of its host star. This method, known as transmission spectroscopy, has proven crucial in piecing together the planet's atmospheric composition. K2-18b is classified as a transiting exoplanet, meaning its orbit causes it to pass between us and its star, temporarily dimming the starlight. These transits allow telescopes like JWST to capture the faint chemical fingerprints of its atmosphere, bringing us closer than ever to understanding what lies beyond our solar system. The exoplanet's brightness dims as it passes in front of its host star, a phenomenon that allowed NASA's K2 mission to initially detect it. During these transits, some of the starlight filters through the exoplanet's atmosphere before reaching telescopes like the James Webb Space Telescope, JWST. As the light passes through, it carries unique spectral fingerprints that astronomers analyze to determine the atmospheric gases present. To validate their current findings and gather deeper insights into K2-18b's climate, the research team plans further observations using JWST's mid-infrared instrument, MIRI. Ultimately, Their goal is to search for potential signs of life on habitable exoplanets, an endeavor that could radically transform our understanding of the universe. In addition to studying exoplanets, JWST has made other astonishing discoveries. Astronomers using a telescope have detected complex organic molecules, similar to those found in smog or smoke, within a distant galaxy. This marks the earliest known detection of such molecules in the universe, which I find both awe-inspiring and slightly unsettling. These findings are reshaping our very understanding of cosmology. These molecules, known as aromatic hydrocarbons, were discovered in a galaxy that formed when the universe was just 10% of its current age. On Earth, they're commonly found in petroleum, coal, and polluted air, and they consist of dozens or even hundreds of atoms. What makes this discovery so remarkable is the sheer complexity of these carbon-based molecules and how early they appeared after the Big Bang, challenging existing cosmological models. To put into perspective, the light from this ancient galaxy began its journey less than 1.5 billion years after the Big Bang. Today, the universe is estimated to be around 13.8 billion years old, meaning we are observing one of the earliest stages in cosmic history. JWST's unprecedented capabilities made it possible to detect these intricate molecules, offering insights we could never obtain before. With its sharp resolution, scientists can now pinpoint the exact locations of these molecules within galaxies, rather than merely confirming their existence. Interestingly, the distribution of these molecules in the galaxy SP4-1847 is uneven, and researchers have yet to understand why. Even more astonishing is that this galaxy, despite being only 1/10 the age of the Milky Way, had already built up as much carbon and oxygen as our own. As we continue venturing into the cosmic unknown, equipped with ever-advancing technology and insight, we are constantly reminded of the universe's vastness and complexity. Each new discovery brings us closer to unraveling the secrets written in the stars. With every observation, JWST is helping redefine what we know about the origins and evolution of the cosmos. The identification of complex organic molecules in the early universe raises the tantalizing possibility that the building blocks of life may exist, or have once existed, in regions we previously deemed inhospitable. If we could peer even further back in time, might we discover more of these molecules, even closer to the Big Bang itself? It's a question that sparks deep reflection about our science, our origins, and what lies ahead in our exploration of the universe. If you found this discovery as fascinating as we did, share your thoughts in the comments. And don't forget to subscribe and turn on the notification bell for more updates as we journey further into the stars with the James Webb Space Telescope, our most powerful eye on the cosmos. The detection of compounds in the atmospheres of exoplanets like K2-18b opens exciting new possibilities for studying potential biosignatures on planets that share certain characteristics with Earth. Molecules such as methane and carbon dioxide, often linked to biological activity on our planet, have been identified, but their presence alone doesn't confirm life. Instead, it signals a need for deeper investigation into whether the conditions on these worlds could support life. The James Webb Space Telescope, JWST, represents a major advancement in this field, enabling scientists to analyze exoplanet atmospheres with remarkable precision. Beyond detecting basic elements, JWST can identify complex molecules that might indicate the presence of life. This level of detail is vital to assessing the habitability of distant worlds. As our knowledge grows, so does our capacity to detect subtle signs of life, whether through atmospheric gases, organic compounds, or other possible markers of biological processes. In addition to studying exoplanets, JWST is offering transformative insights into formation and evolution of galaxies. By observing some of the most distant galaxies, astronomers can trace the history of star formation, track elemental distribution, and study the mechanisms behind galactic growth. These observations are helping us understand how galaxies like the Milky Way came to be. The recent discovery of aromatic hydrocarbons in galaxies that formed relatively early in the universe's history highlights just how much we're learning about the cosmos. It suggests that life's essential building blocks may have existed far earlier than once believed, offering new perspectives on the origins of life. Each new JWST discovery brings us closer to answering some of humanity's most profound questions. Are we alone in the universe? What are the necessary conditions for life? How did the universe evolve? And what lies ahead? JWST provides the tools to explore these questions by giving us an unprecedented view into the most remote regions of space and time. Its ability to study early galaxies, probe exoplanet atmospheres, and uncover the processes that govern the cosmos is paving the way for discoveries that could reshape our understanding of existence itself. The telescope's mission isn't just about observing the universe. It's about redefining how we see ourselves within it. As JWST continues to scan the skies, its findings will inspire new generations of scientists and space explorers. From identifying distant planets to investigating the origins of stars and galaxies, JWST stands at the forefront of astronomy. Its work symbolizes humanity's unrelenting curiosity and our drive to uncover the mysteries of the universe. With each revelation, JWST pushes the boundaries of knowledge and brings us one step closer to answering questions that have captivated us for centuries. The future of space exploration is being shaped now, and the James Webb Space Telescope is leading the way.